Everyone able to find it? You guys good?
Oh, yeah, what's
Found it.
How many graphs did we do yesterday?
How many graphs did we do yesterday?
Yeah.
Yesterday,
We did
so yesterday we did example 5, and then we were doing these.
Okay.
We don't have five.
Not yet, we'll be handing that out. All right, today we're going to be focusing on graphing two, not new functions, but new for us graphing them, and it's going to be secant and it's going to be cosecant. What's the sister for secant? Cosine, yep. So the way we graph these sister functions, secant and cosecant, is the first thing we have to kind of think about is what cosine and sine look like. Because remember, what makes a sister function is that it's the reciprocal of kind of the main player, the main function. So secant being the sister for cosine means that it's just the reciprocal of cosine. So if cosine's x over 1, secant's 1 over x. The first thing we do when we're graphing secant of x is we plot the points for the parent function of cosine of x. And we're not going to connect them, we're just going to plot the points because those points are going to be really important in telling us what secant's doing at those same spots. So does cosine start at the top or does it start at the midline? The top, yep. And remember on a unit circle, well, first off, for our graph, we're counting about 45 degrees, that same kind of base scale. I know we switched it up on you for one of the examples yesterday, but almost every time we'll be using that 45 degree or pi over 4 scale. And with that pi over 4 scale, at x equals 0, cosine equals 1. At x or theta equals 90 degrees, what's cosine equal on our unit circle? 0, yep. Another way to think about it, that parent function of cosine, the midline's just y equals 0 because there's no vertical shift. So every time it has to drop down to that k, it has to drop down to that midline, it's just going to equal 0. And then at pi, what's cosine equal? -1, yep. And then at 270 degrees, cosine again is 0. And then finally at the end of the period at 360 degrees, cosine returns where it started, and it comes up and it equals 1.
-1 or -2?
Thank you. Yeah, I was counting. I was plotting them like cosine was equaling 2. My brain hadn't quite warmed up yet. Cosine equals 1 at 0. Cosine equals -1 at pi, or 180 degrees. So now that we have our points for that positive period of cosine, we're also going to do one in the negative direction. And remember, we're not connecting these points, we're just plotting them. So please don't connect them. When we're going in the negative direction, cosine of -90 degrees equals 0. From there, cosine of -180 degrees is the same as cosine of 180 degrees. -180, +180. They're both going to be at -1. And then just following the pattern, it's going to be 0, and it's going to be 1. So those are kind of all the main points of 2 periods of cosine. So make sure you have those points plotted down. Please don't connect them, because remember we're graphing secant here. We're not actually graphing the cosine. We're just using the main points to help us out. So when cosine equals 0, cosine of x equals 0, it really equals 0 over 1. So when cosine of x equals 0, secant of x, remember, is the reciprocal. So when cosine of x equals 0 over 1, secant of x is going to equal 1 over 0. And who remembers what we call it when there's a 0 in the denominator? Undefined, yep. And another way the way we think about undefined points, undefined x values graphically, is that's where an asymptote's going to be. So every time cosine equals 0, for the secant graph, we're going to have an asymptote. And the way we show that is just with a dotted line every time cosine equals 0. So we're going to have one there. We're going to have an asymptote there. Every time cosine of x gives us y equals 0, secant is going to be undefined. It's just going to give us an asymptote. So that was nice. That's one reason we plotted the points, because we know every point on the midline of cosine is going to give us an asymptote. So that's one reason we plot the points when we're graphing secant. We plot the points for cosine of x. Another reason is when cosine of x equals 1, if you flip 1 over 1, it's still going to be 1 over 1. So when cosine of x equals 1, secant of x equals 1. When cosine of x equals negative 1, secant of x equals negative 1. Any questions with that? So all of these points, the top and bottom points on our graph, are going to be points on our secant graph as well. And then from there, as you probably learned a bunch in algebra and classes before this, when we have an asymptote, we get closer and closer to that asymptote, or that value, without ever getting there. And the way we show that for our secant, it's going to be like this. It's going to come down, run through the point, and get taller and taller. Kind of looks like a parabola. It's not. It kind of looks like one. So then for the positive points, or the top of secant of cosine, our secant is just going to have kind of that, it comes down and it gets to y equals 1, and then it goes up positively in both directions. And then at the bottom points, or the k minus a points, it's just going to flip on us. Just like that. And remember, our values never reach, they get closer and closer to our asymptotes, but they don't reach. And like I said, it's a repeating pattern, like pretty much everything in trig is when we're graphing. So every single one of those bottom points is going to go down, and every single one of those positive points is going to go up. I realized my count was one off, so I adjusted that last point. And there we go. Even though I didn't draw them, I'm sure you guys can see there'd be an asymptote there and an asymptote there as well. There's going to be, the asymptotes are going to be evenly spaced apart, and we'll get to that. But this right here, that's our graph of secant, our parent graph of secant. So now that we have our parent graph, it's time to talk about domain, range, period, and asymptotes. First things first, let's talk about our asymptotes. So our asymptotes are going to be every time cosine of x equals 0. So here, our asymptotes are pi over 2. And then the way that we write down to get that they're repeating, and they're going to be repeating on and on forever, is it's x over 2 plus or minus pi n. And I got pi because every single one of these asymptotes are 4 jumps, so 180 degrees are pi away from one another. And then n tells me that no matter how many pi jumps you make, forever and ever, you're going to reach another asymptote. For example, here, if I'm going in the negative direction, negative 1 pi gets me to an asymptote, negative 2 pi gets me to an asymptote, negative 50 pi, if I start at pi over 2, will get me to an asymptote. That's what that n's saying. You plug in any number for n, you're still going to end up at an asymptote. So now that we have our asymptotes, we're going to talk about our domain. And the first thing we write for our domain, same as before, we're going to say all real numbers. And then after we say all real numbers, we have to exclude the asymptotes. So we're going to say all real numbers, but when x equals, I got to zoom in a little bit. When x equals pi over 2 plus or minus pi n. So that's how we write out our domain. And you can kind of see that. It's going to be every x number except for when we have an asymptote. From there, our range is pretty similar, just a little bit different than what we've been doing for sine and cosine. The bottom range, think about it, the lowest y value, well, these are going to go down forever. So our lowest y value is going to be negative infinity. And then there's a break in our range. So we're going to say negative infinity to the low point, which here is negative 1. And that negative infinity is going to have that soft bracket. The negative 1, real value, is going to give us a square bracket. From there, we're going to use the big U. That tells us union. And we're going to use another square bracket. And for this one, we're going to say from 1 to positive infinity. Overall, our range is saying that's pretty much everything except the values between negative 1 and 1, which we can see on our graph. Last thing, I guess I could have filled this out first, but our period is just going to be 2 pi. The period for secant or cosecant is going to be the same thing as what your period would have been for cosine or sine. Any questions on the parent graph of secant x? Cool, so now that we have secant x, we're going to move on to cosecant of x, and it's kind of a very similar pattern. Because what's the sister function for a cosecant? Sine, yep. So the first thing we're going to do, same thing. We're going to plot out 2 periods worth of points for sine x, and it's just the parent function. So I want you to try that on your own. Remember, sine x starts at 0, starts on the midline, and then it goes up, back down to the midline, down, and then back up. So just take a second and try to give me 8 points for the parent function of sine x. And remember, what we're really after is cosecant. So don't connect the points. Just plot them out.
Do you have a question? Okay. So right now, the first thing we're gonna do is we're gonna plot 8 points, or a positive period and a negative period, of the sister function of cosecant. And the sister function of cosecant is sine. So remember, cosecant of x is 1 over y. And then the parent function of sine. Oh, you have it. So all we're doing is we're taking these points, those same exact points, and we're plotting them here. Because these main points, we're not going to connect them like we did for sine, but they're going to be super important and telling us what happens for cosine. So just take a second to plot out those points.
I didn't even notice that until I was getting the instructions yesterday. I was like, I should have pressed it.
I did my thesis, and then I
What?
started following diagram. So now I have.
Yep, so you're just going, we'll go over it together. But we're just plotting the points for sine x. Yeah, we'll go over it.
All right, so if I'm looking to graph the 8 points of sine x, remember kind of the nice thing about the parent functions is we don't have to worry about vertical shift, horizontal shift, period change, anything like that. It's just the base function. And so I think some of you guys, you already know how to do your homework. You're kind of overthinking it because all of a sudden there wasn't an amplitude, there wasn't anything like that. And remember, for our parent functions, the amplitude is 1. And the midline, or vertical shift, or K, is 0. Also, the horizontal shift, or phase change, is 0, because it's just our parent function. And our period is 2 pi. So with all that information, I'm sure you can plot the points. And if I was looking to plot the points, there's no horizontal change or phase shift, so that would be my first hash mark. Then my second hash mark would have to be 2 pi or 360 degrees away. We count by 45 degrees, so it's going to take 8 jumps to be 2 pi or 1 period away. From there, we take the middle in the middle of the middles, and those are going to be my 5 points for sine. Remember, sine starts on the midline, and here, because there's no vertical shift, that midline's just going to be at y equals 0. Our k is just 0. So our points at the beginning, middle, and end are all going to be at 0. And then our k plus a, our a here is 1 because it's just the parent function. 0 plus 1 gives us 1. And then 0 minus 1 gives us negative 1. So that is how I would plot out the 5 base points for the parent function sine of x. And then moving in the negative direction, I had 4 hash marks with the same spacing. I follow the pattern. We're starting at a midpoint and it came high, so we have to go low. Return to the midpoint, high, and then back where we started. So that right there is 4 pi's worth or 2 periods worth of sine points. And now because of those points, we're going to be able to plot out cosecant of x. Remember, wherever sine of x equals 0, we would flip it to give us cosecant of x. And so cosecant of x would equal 1 over 0 or would be undefined. And every time there's an undefined point on our graph, we write an asymptote. So take a second, and I see 5 points where where it's going to be y equals 0. So that shows us where sine of x is going to be equal to 0. So write in your asymptotes at those 5 points. Give me a thumbs up if you're with me and plotting those asymptotes at the 0 are making sense. Good. So now, like I said before, these aren't parabolas, but one way to kind of think about it is the high points are going to be the minimum of an upwards opening parabola, and the low points, or the k minus a points, are going to be the vertex or the maximum of a down opening parabola. So the way we would draw this, oh, I thought I was in blue. At the points that sine of x is going to be at the top of its graph, well, cosecant of x is going to be at the bottom of an upwards opening U shape. And then it just flips for the bottom points. And then from there, once you have a top and bottom, it just kind of repeats. And there it is. The blue represents a graph of cosecant of x. And not just a graph, but the parent graph. From there, we would describe our domain, range, period, and asymptotes the same way we did for secant of x. I'll start with the period this time. Remember, the period is going to be the same as what its sister function would have been. So just the parent function cosecant of x is going to have the same period as its sister sine of x, and it's just going to be 2 pi. The asymptotes here, well, the first asymptote is just at 0. So we write 0, and then we go plus or minus. And it's going to be plus or minus pi n.
Pi n.
Yep, pi n.
Where'd you get 0? Like, where are you going 0?
Yep, so our first asymptote is going to be at 0.
Okay.
And then from that first asymptote, we have to figure out what the jump we're going to have to make to get to the other asymptotes. And here we see that the asymptotes are pi away from one another. So we're going to have to be jumping by pi. On other problems, it'll be easier to see. But that pi value, the distance that the asymptotes are separated for cosecant and secant, will always be half of the period. So if the period is 2 pi, your asymptotes are going to be separated by pi. Yep.
So for the secant graph, why is the asymptote pi?
Yep, and really the reasoning for that goes all the way back to our cosine and sine. Sine starts at 0, cosine starts at 1 and then goes down to 0. So cosine isn't 0 until pi over 2. And so when cosine 0, that's when secant gives us the asymptote. So now our domain, remember the first thing we write is that it's going to equal all real numbers. It's kind of one of those statements. It's everything but. Here it's all real numbers, but where there's an asymptote, and that's where x equals 0 plus or minus pi over n. Finally, the range. The range is going to be two-part always for secant and cosecant. Here, the negative range goes all the way down to negative infinity. And then the ones that are opening down come all the way up and touch -1. Oh, and then we write the union, the big U. And then we do the same thing for the positive. The positive square bracket, start at y equals 1 and then go all the way up to positive infinity. So now that we've graphed the parent function, we can start having some transformations. This should be on your next page, example 7. And we have f of x equals 2 cosecant of x plus pi over 2. And the first thing we do here is we're not graphing the sister function. We're not graphing sine x, but we're graphing what sine x would look like for the points. So really, we can think of this as 2 sine x plus pi over 2. If we were looking at that, we would say that our a value is 2. We would say that our k value is 0. We would say that our b value, there isn't one there, so our b value would be 1, which then gives us just 2 pi as our period. Finally, our horizontal shift, it would be the same thing. We set inside the parentheses equal to 0. X plus pi over 2. We set that equal to 0. So then our horizontal shift or our phase shift is going to be x equals negative pi over 2. So by looking at its sister, we can get all of these points of information. And from there, and this is why it's so important to be able to graph sine and cosine, we can graph those base 8 points of 2 periods, and then from that, we transform it into a cosecant or a secant graph. So as if we were looking to graph sine here, which we're not, we're just looking to plot its main points. The first hash mark we would make is that x equals negative pi over 2. Horizontal shift, it would be right there. That's going to be the beginning of our first period, our starting line. From there, we would make a hash mark 1 period away, and here our period is 2 pi. So we have to make it 8 jumps away. Because every jump is pi over 2, or 90 degrees, or 45 degrees, sorry. Once we have the beginning and end of our period, we're going to take the middle, in the middle of the middles, to give us 5 values. From there, we can kind of think about, is there a vertical shift? And here, our k value is 0, so there isn't one. And then our a value, or our amplitude, is 2. So our points are going to follow that same pattern. Remember, if you look back here on the board, it's a cosecant graph. So we're looking at the sine pattern, because sine is the sister to cosecant. It's going to go k, K plus A, K, K minus A, and K for those 5 points. Our K is 0. So for the first, third, and fifth points, our K is just going to be 0. If you look up on the board, I plotted it. From there, for K plus A, 0 plus 2 is going to give us 2. And for K minus A, 0 minus 2 is going to give us negative 2. Remember, we're not connecting these points, we're just plotting them. And I'm going to go in the negative direction for our second period because it looks like we have a little bit more room. Remember, I need to add 4 hash marks on following the same spacing. Our spacing was every other one. And then from there, I'm just going to follow the pattern. That first point is going to go down, and then midline, and then up, and then midline. For cosecant and secant, even when it's all dressed up like it is here, every point that's on the midline is going to be an asymptote. So here, all of our asymptotes are going to, again, be at the points where y equals 0. From there, it's just the same pattern as the parent. The high points are going to open up, and the low points are going to open down. From that, the first thing we can fill in is our period. Remember, we said our period was just going to be 2 pi. We also know our phase shift and our vertical shift right off the bat. Our phase shift or horizontal shift was left by pi over 2. And our vertical shift was just none. There wasn't any. From there, our vertical asymptotes, our first one occurred at the horizontal shift, so at negative pi over 2. And then they're separated by half of the period, so plus or minus pi n. From there, our domain is all real numbers, but x cannot equal any of the vertical asymptotes. So negative pi over 2 plus or minus pi n. Finally, the range, looking at the graph, the negative points come from negative infinity and go up to negative 2. And then the positive points are from 2 to positive infinity. So the way we would write that is negative infinity to negative 2, square bracket, union positive 2 to positive infinity.
For domain, if we just wrote negative infinity to infinity, would that be wrong?
Yep. Because remember, the domain is saying, where is there a possible input? Where is there a possible x value? It's not possible to input a number where there's an asymptote and get an output. So we have to exclude the asymptotes for our domain. Yep.
For the last, you didn't put right? Not for the domain.
We did. So for the last two, it looked a little bit different because this one was cosecant, but this one was x equals all real numbers, x does not equal, thank you, I see what you're saying. Yep, x does not equal. Thank you, good question. Go back and fix those on your parents. X does not equal the asymptotes. Good catch, thank you. Now for example 8, what's the sister for secant? Cosine. So one way to think about this is cosine of 2x plus pi plus 1. If you think about it like that, you just have to plot the points for this. And then remember that you're actually graphing a secant. So here, our k is going to be 1. What's the amplitude going to be? 1. Remember, if amplitude isn't there, we say it's 1. Because it's multiplying the whole thing. So our k is 1, our amplitude is 1. Our period is going to be 2 pi divided by 2, because our b value is that 2. So our period here is just going to be pi. We said our vertical shift was going to be up 1. And then our phase shift, or our horizontal shift, is going to be 2x plus pi equals 0. If you solve that out, subtract pi from both sides, and then divide both sides by 2. Our phase shift is again going to be left by pi over 2. So remember, once we know our phase shift, we're going to make our first tally mark at negative pi over 2. From there, we look at our period, and our period's pi. So we're going to jump forward by a period. Here, since it's only pi, that's only going to be 4. Our jump's going to be half as big. From there, we mark the middle in the middle of the middles. We could go left or right here, seeing as we're pretty middled up. I'm going to go right. Remember, you just add 4 with the same spacing. If you wanted to plot the points and then add the 4 tally marks, like we've been doing, that's fine. From there, remember it's cosine. So cosine starts at the top. It starts at k plus a. Our k and a were both 1. So we're going to start at 2. And then go down to 1. And then 0. And back up to 1. 2. 1. 0. 1. 2. And now this graph is a little bit different. Because remember, I said not that the asymptotes were going to be where the points equal 0, but the asymptotes are going to be where the points are on the midline. What's our midline here? Yep, our midline is y equals 1. Another way to think about it is our midline is the vertical shift. So every point that is on your midline is going to be an asymptote. Here, the asymptotes are going to occur at the points that are at 1. From there, we follow the same pattern. The top points open up, the bottom points open down. And they're a little skinnier this time. Make sure they both stay inside their asymptotes. And there it is. Based off of plotting the points of cosine and then knowing the pattern of secant, we were able to graph this secant function. From there, we can see our first vertical asymptote was actually at negative pi over 4. And then every asymptote is separated by a jump of half of the period. So here, it was plus or minus pi over 2 times n.
Wait, where'd you get, like, where'd you get negative pi?
I got negative pi over 4 because I looked at that first asymptote. And it was at x equals negative pi over 4. To be honest, when you're finding your vertical asymptotes, you can look at the first positive one, you can look at the first one, whichever. You pick one, and then you define the jump between them.
Oh.
From there, our range, similar to the one before, negative infinity to 0, because here these points are now at 0. Square bracket union, square bracket 2 to positive infinity. And then our domain, remember, all real numbers, but x does not, thank you. It's a great reminder. It was awesome that you saw that. X does not equal, and then we just insert where the vertical asymptotes are. So negative pi over 4 plus or minus pi over 2n. On your way out, you can grab homework 5. That'll be due
On Friday.
It'll be due on Friday. Homework 5 will be on this desk right here.